T11.5. A significance test was performed to test the null hypothesis mu equals 2 versus the alternative hypothesis mu not equal to 2. A sample size of 28 produced a standardized test statistic of t equals 2.051. Assuming all conditions for inference were met, which of the following intervals contains the p-value for this test? All right, so let's sketch a picture of a t distribution with 27 degrees of freedom. Remember, it's going to be n minus 1. All right, our t distribution is centered at 0. Our test statistic is 2.051, so that'll be somewhere in the right tail. The alternative is two-sided, okay? So that means that we're going to be shading the right tail as well as the equivalent side of the left tail, right? So because of the symmetry of this distribution, right, I can just use opposites to identify what the second boundary value is. All right, so what I'll do is I'll use my calculator to find the area of the left tail. Actually, let's just go area of the right tail. I don't feel like typing in negative signs. All right, find the area of the right tail, and then we'll double it to get the overall p-value. All right, so TCDF, lower bound equals 2.051, upper bound equals 999, degrees of freedom equals 27, okay? And then whatever that equals, right, we'll multiply it by 2 to get the p-value. All right, so just kind of listen along as I do the calculation off screen, okay? Lower bound 2.051, upper bound 999, degrees of freedom 27. All right, so the area of one tail alone is 0.0250. So the area of two tails would be 0.0500. All right, so that is, well, okay, so rounding to 4 digits, it's exactly 5. If we were to go record more digits, it's 0.0500864,104. Okay, and then, you know, technically speaking, I don't want to move all of it. The area of one tail was 0.02504,32052. Okay, so I went several digits. This is the p-value right here. So it's slightly greater than 5%, which means I'm going to choose option D. Okay, it's greater than 5%, barely, but less than 10%.